Welcome to solverfy.
So we want to find, again, we need to find an equation that represents displacement in terms of time. So we can say that J is going to be an impulse. So J being an impulse, by definition, this would be equal to the change in P. So delta P would denote the change in momentum. And this would be equal to m times the change in velocity, given that the mass of the object does not change. And this is giving us m times v initial minus v. And because we know that the object is coming to a stop, we're going to say that v is going to equal to 0. So the change in momentum, or the impulse in this case, would be equal to the mass times the original velocity. The original velocity can then be is then going to be equal to the impulse divided by m, and this would be equal to the maximum velocity, which the formula for the maximum velocity would be equal to the amplitude times the angular velocity. Therefore, we can say that um, v max is going to be equal to the amplitude times the square root of the spring constant divided by m, the mass. So we can then say J, the impulse, over mass will be equal to the amplitude times the square root of the spring constant divided by the mass. We can solve for the amplitude. So the amplitude would simply be equal to the impulse divided by square root of the spring constant multiplied by the mass. And we know that the general formula would be equal to a sine of omega t. Therefore, applying this general formula to the specific system, the position is going to be equal to j over the square root of k times the mass, or the spring constant times the mass, times sine of t times the square root of the spring constant divided by the mass. And so this would be our final answer here. That is the end of the solution. Thank you for watching.